Yes, in the United States, X2 should be bonded to the metal cabinet. As per the 2023 National Electrical Code, Article 450.4, grounding of stationary single-phase transformers, specifically 450.4b2 secondary neutral grounding, the secondary neutral of a single-phase transformer shall be grounded. However, there's an exception in 450.4b2 exceptions, secondary neutrals of control transformers, as defined in Article 725, and dry-type transformers rated 5 kVA or less shall be permitted to be ungrounded. Additionally, 450.4c metal enclosures states that metal enclosures for transformers shall be grounded in accordance with Article 250. Given that the transformer is a 5 kVA single-phase dry-type transformer with a 480 volts primary and a 120 volts secondary, it falls within the exception allowing it to be ungrounded. Nevertheless, the metal enclosure must be bonded to the secondary neutral, and this is commonly achieved by connecting the X2 terminal to the metal cabinet. It is important to consult the latest edition of the National Electrical Code in local regulations for specific requirements and interpretations, as code requirements can change over time and may vary by jurisdiction. When installing a transformer, always prioritize safety and ensure that all work is performed by qualified personnel. The function of grounding and bonding is crucial for electrical safety. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metallic parts of an electrical system to create a low impedance path for fault current. This reduces the risk of electric shock by ensuring that all metallic parts are at the same electrical potential. Now let's delve deeper into the NEC requirements related to grounding and bonding of transformers. Article 250 provides comprehensive guidelines for grounding and bonding electrical systems. It covers everything from grounding electrode systems to equipment grounding conductors. When grounding a transformer, it's essential to establish a solid connection to a grounding electrode system. This system typically consists of ground rods, ground plates, or a metallic water pipe that is in direct contact with the earth for at least 10 feet. The size of the grounding electrode conductor is determined by NEC Table 250.66, based on the size of the ungrounded conductors. Equipment grounding conductors are used to connect the metal enclosure of the transformer to the grounding electrode system. The size of the equipment grounding conductor is determined by NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. In addition to grounding the transformer, it is also important to bond all metallic parts of the electrical system together. This includes metal conduits, metal enclosures, and other metallic equipment. Bonding creates a low impedance path for fault current, which helps to prevent electric shock. The bonding conductors must be sized according to NEC Table 250.102, based on the size of the ungrounded conductors. When installing a transformer, it's important to follow the manufacturer's instructions and all applicable electrical codes. This will help to ensure a safe and reliable installation. Always use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools, when working with electrical equipment. If you are not comfortable working with electrical equipment, it's best to hire a qualified electrician. Here are some additional considerations for grounding and bonding transformers. Firstly, consider the location of the transformer. If the transformer is installed in a damp or wet location, it's especially important to ensure that the grounding and bonding are done correctly. Secondly, consider the type of load that the transformer will be serving. If the transformer will be serving a sensitive electronic load, it may be necessary to provide additional grounding and bonding to protect the equipment from damage. Thirdly, consider the size of the transformer. Larger transformers require larger grounding and bonding conductors. Fourthly, consider the impedance of the grounding electrode system. A low impedance grounding electrode system is essential for providing a safe and effective grounding path. Fifthly, consider the voltage drop in the grounding and bonding conductors. Excessive voltage drop can reduce the effectiveness of the grounding and bonding system. Sixthly, consider the potential for corrosion. Grounding and bonding conductors can corrode over time, which can reduce their effectiveness. It's important to protect the conductors from corrosion by using appropriate materials and coatings. 7th, consider the presence of harmonics. Harmonics can cause excessive current to flow in the grounding and bonding conductors, which can overheat them. It's important to mitigate harmonics by using appropriate filtering techniques. 8th, consider the impact of grounding and bonding on other electrical systems. Grounding and bonding can affect the performance of other electrical systems, such as communication systems. It's important to coordinate the grounding and bonding of all electrical systems to avoid interference. 9th, consider the need for surge protection. Surge protection devices can help to protect electrical equipment from damage caused by lightning strikes and other voltage surges. It's important to select surge protection devices that are appropriate for the application. 10th, consider the need for a regular inspection and maintenance. Grounding and bonding systems should be inspected and maintained regularly to ensure that they are functioning properly. This includes checking the connections for tightness and corrosion, and testing the impedance of the grounding electrode system. Remember, grounding and bonding are essential for electrical safety. By following the NEC requirements and using good engineering practices, you can ensure that your electrical system is safe and reliable. Always consult with a qualified electrician if you have any questions about grounding and bonding. The XU terminal on a single-phase transformer is typically the designated connection point for the neutral conductor of the secondary winding. In a grounded system, this terminal is connected to the grounding electrode system, establishing a reference point for the electrical potential. Bonding the XU terminal to the metal cabinet provides a path for fault current to flow back to the source in the event of a ground fault within the transformer or connected equipment. This low impedance path helps to quickly trip the overcurrent protective device, such as a circuit breaker or fuse, isolating the faulted circuit and minimizing the risk of electric shock or fire. Without proper bonding, a ground fault could cause the metal cabinet to become energized, posing a significant safety hazard to anyone who comes into contact with it. The specific requirements for bonding the XU terminal to the metal cabinet may vary depending on the size and type of transformer, as well as the applicable electrical codes and standards. It's important to consult the manufacturer's instructions and the relevant codes to ensure that the bonding is done correctly. In some cases, the bonding may be achieved by directly connecting the XU terminal to the metal cabinet with a bonding jumper. In other cases, a separate grounding conductor may be required to connect the metal cabinet to the grounding electrode system. Regardless of the specific method used, the bonding connection must be secure and reliable to ensure that it can effectively carry fault current. The size of the bonding conductor is typically determined by the size of the overcurrent protective device protecting the circuit. The NEC provides tables that specify the minimum size of grounding and bonding conductors based on the ampere rating of the overcurrent device. It's important to use the correct size conductor to ensure that it can safely carry the fault current without overheating or melting. In addition to bonding the XU terminal to the metal cabinet, it's also important to bond all other metallic parts of the electrical system together. This includes metal conduits, metal enclosures, and other metallic equipment. Bonding creates a low impedance path for fault current, which helps to prevent electric shock and minimize the risk of fire. The bonding conductors must be sized according to the applicable electrical codes and standards. When working with electrical equipment, it's always important to follow safe work practices and use appropriate personal protective equipment. This includes wearing safety glasses, gloves, and insulated tools. If you're not comfortable working with electrical equipment, it's best to hire a qualified electrician. Here are some additional tips for grounding and bonding transformers. Firstly, always consult the manufacturer's instructions and the applicable electrical codes and standards before installing or working on a transformer. Secondly, use the correct size grounding and bonding conductors. Thirdly, ensure that all grounding and bonding connections are secure and reliable. Fourthly, inspect grounding and bonding connections regularly to ensure that they are in good condition. Fifthly, protect grounding and bonding conductors from corrosion. Sixth, Use appropriate personal protective equipment when working with electrical equipment. 7th, hire a qualified electrician if you're not comfortable working with electrical equipment. Grounding and bonding are essential for electrical safety. By following these tips, you can help to ensure that your electrical system is safe and reliable. Always remember to check local and national codes as they can vary. The information here is for educational purposes and should not substitute the advice of a licensed electrician. If you're dealing with a 5 VA transformer with a 480 volts primary and 120 volts secondary, it's crucial to understand the grounding requirements specific to control transformers, as highlighted in the NEC. While the exception in 450.4b2 permits ungrounded secondaries for control transformers rated 5 VA or less, this doesn't negate the requirement to ground the metal enclosure, as stated in 450.4c. Grounding the metal enclosure ensures that any fault current within the transformer or its connected components will have a path to ground, tripping the overcurrent protection device and preventing a dangerous voltage buildup on the enclosure. The X2 terminal, typically the neutral point of the 120 volts secondary, is often the most convenient point to bond to the metal cabinet. This creates a low impedance path for fault current to flow back to the source, ensuring rapid clearing of the fault. It's important to note that even if the secondary is ungrounded, the metal enclosure must still be grounded to comply with NEC Article 250. This grounding protects personnel from shock hazards in case of insulation failure within the transformer. To properly bond the X2 terminal to the metal cabinet, use a bonding jumper of appropriate size as determined by NEC Table 250.102. The jumper should be securely connected to both the X2 terminal and the grounding point on the metal cabinet. Ensure that the connections are clean and free of corrosion to provide a reliable electrical path. Additionally, inspect the grounding system regularly to verify its integrity. Check for loose connections, corrosion, and any signs of damage. A properly grounded and bonded transformer is essential for electrical safety. It protects personnel from shock hazards and prevents equipment damage. Always consult with a qualified electrician to ensure that your transformer is installed and grounded correctly. Remember that electrical codes and standards may vary depending on your location, so it's important to stay up to date on the latest requirements. By following these guidelines, you can help to ensure a safe and reliable electrical system. Always prioritize safety when working with electrical equipment. They energize the circuit before making any connections or performing any maintenance. Use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. If you're not comfortable working with electrical equipment, it's best to hire a qualified electrician. They have the knowledge and experience to safely and properly install and maintain your electrical system. By taking these precautions, you can help to prevent electrical accidents and injuries.